Extensive games and their strategic form. A game in a strategic form is a static description of an interactive situation where players act simultaneously. A detailed dynamic description is an extensive game where players act sequentially, where some moves can be made by a chance player and where each player's information about earlier moves is modeled in detail. Extensive games are a fundamental representation of dynamic interactions which generalizes other models like repeated and multi-stage games or games with incomplete information. The basic structure of an extensive game is a directed tree. The nodes of the tree represent game states. Trees rather than general graphs are used because then a game state encodes the full history of play. Only one player moves at any one state along a tree edge. The game starts at the root initial node of the tree and ends at a leaf terminal node, where each player receives a payoff. The non-terminal nodes are called decision nodes. The player's possible moves are assigned to the outgoing edges of the decision node. The decision nodes are partitioned into information sets. All nodes in an information set belong to the same player and have the same moves. The interpretation is that when a player makes a move, he only knows the information set, but not the particular node he is at. In a game with a perfect information, all information sets are singletons and can therefore be omitted. We denote the set of information sets of player I by HI, information sets by H, and the set of moves at H by CH. Figure 3.3 shows an example of an extensive game. Moves are marked by uppercase letters for player 1 and by lowercase letters for player 2. Information sets are indicated by ovals. The two information sets of player 1 have move sets LR and ST, and the information set of player 2 has move set LR, little l, and little r. A play of the game may proceed by player 1 choosing L, player 2 choosing R, and player 1 choosing S, after which the game terminates with payoff 5 and 6 to players 1 and 2. By definition, move S of player 1 is the same no matter whether player 2 has chosen L or R, because player 1 does not know the game state in his second information set. At some decision nodes, the next move may be a chance move. Chance is here treated as an additional player 0 who receives no payoff and who plays according to a non-behavior strategy. A behavior strategy of player 1, player I, is given by a probability distribution on CH for all H in HI. The information sets belonging to the chance player are singletons. A pure strategy is a behavior strategy where each move is picked deterministically. A pure strategy of player I can be regarded as an element CH where H in HI of the multiplication of CH where H in HI. That is, as a tuple of moves like LS for player 1 in figure 3.3. Tabulating all pure strategies of the players and recording the resulting expected payoffs defines the strategic form of the game. In figure 3.3, the strategic form of the extensive game is shown at the top right. with payoff matrices A and B to player 1 and player 2. Given the strategic form, a player can play according to a mixed strategy, which is a probability distribution on pure strategies. The player chooses a pure strategy, which is a complete plan of action according to this distribution, and plays it in the game. In contrast, a behavior strategy can be played by delaying the random move until the player reaches the respective information set. It can be considered as a special mixed strategy since it defines a probability for every pure strategy where the moves and information sets are chosen independently. We consider algorithms for finding Nash equilibria of an extensive game with the tree together with the described game data as input. The strategic form is bad for this purpose because it is typically exponentially large in the game tree. As described in the subsequent sections, this complexity can be reduced in some cases by considering sub-games and corresponding sub-game perfect equilibria. The reduced strategic form of the game is smaller but may still be exponentially large. Reduction from exponential to linear size is provided by the sequence form, which allows one to compute directly behavior strategies rather than the mixed strategies.